So I welcome you all for the day one session of Azure Data Engineering and Data Bricks and Power BI. So today's session, I'm not going to deal much about the content and everything, but what I'm going to do is I'm going to tell you the roadmap that we are going to follow with respect to this Azure Data Engineering and Data Bricks and Power BI to make sure that we follow what we are doing. Okay, we follow what we are doing, and we'll be having a concrete understanding how the course roadmap is going to be, and then we'll take it from there. Okay, so I just want to have this class to be an interactive class. Kindly respond uh, with respect to the questions I'm asking by mentioning your messages within the chat window. Okay, among all of you, how many of you are not familiar with respect to cloud computing? Or else, how many of you have been working only on the on-premise? How many of you have been working only on the on-premise, and how many of you are working in the cloud? Can you please let me know? Like any on-premise, Prasanna is on-premise. Then just mention whether it is on-premise or whether it is cloud. How much you are aware of, you can do only on-premise. Sandeep is on-premise. Everyone is on-premise. How about the others? If you could kindly on-premise and IACS. Okay, got it.
Okay.
Well, okay, on-premise. So this is the first time you have been introduced to this cloud computing, either with respect to Azure or AWS or Google, whatever it is, right? Is that my understanding correct?
Yes. Yes, sir.
So, Gian, how about you? Okay, that's okay. So, first thing what we'll be doing is we'll be starting with the Azure fundamentals in terms of what is Azure, what is cloud computing with respect to Azure, and what is the infrastructure as a service, platform as a service, and software as a service. Okay, and what are all the various services that have been offered by Azure. Okay, and within that one, what are the core services that are really required, especially when you are working on a data engineering platform or data analytical platform. Okay, there are some five components that are really required in order to work on this end-to-end data platform applications. Okay, one component happens to be your storage, because we need to store the data. Okay, either the data is stored in the form of databases, flat files, or some other place, that storage is really required. Okay, and we can't use only the databases here, right? Because we can have the option of using structured, unstructured, and semi-structured data also as well. So what are all the different storage options what you are having for the purpose of storing the data in cloud, that we need to understand. And other thing is compute, because when you want to process something, we need to have some CPUs. We need to have something like CPU power. Okay, that CPU power is basically treated as cores, CPU cores. How much compute power is really required? So we need that particular compute also as well. We need. Okay, and the third thing what we need is we need uh, we need something like networking, because all your processing with respect to all your processing with respect to um, data engineering cannot happen on a single system, right? It will be happening on more than one system. It will be happening on more than one system. So when that one is happening on more than one system, obviously what you have to do is you have to you have to use more than one system. You have to use more than one system. And when you're using more than one system, there should be a connectivity between each and everything. So that connectivity is going to be used with the help of this networking. So compute, storage, networking, and database. Along with that one, there is one more thing that is important, which is nothing but your security is important. Security. What is that security? Security means if you have your data that is there in your public cloud, not only your organization's data, but the data that is used by multiple organizations, the data that is used by multiple organizations will be stored in that particular piece, will be stored in that particular piece. So that's why you need to make sure that your data is totally secured in that particular cloud also as well. That's why security is really important. So that's why for any cloud computing platform, there are some core services that you need to understand. What is one is compute, the second one is storage, and third one is database, the fourth one is networking, and fifth one is security. Okay. Once you are good with respect to this computing, all these core services, then you'll be able to jump onto the other services that are offered by different platforms, and then you can start working on that one basically. So that's why welcome to this Azure Fundamentals. And within this Azure Fundamentals, we are going to see what will be covering in this AZ900 Microsoft Azure Fundamentals. As I've told you, right, I'll be focusing on three types of certifications. Three types of certifications. So what are the three types of certifications that I have told you? The three types of certifications that I have told you is I'll be focusing on something like DP 900, which is nothing but your Azure Data Fundamentals. Okay, I'll be focusing on something like DP203, which is of Azure Data Engineering Associate. And before that one, I'll be focusing on this Azure Fundamentals. Azure Fundamentals is AZ900, and then Azure Data Fundamentals is DP900. So DP900, DP03, and AZ900. These are the three things that we are going to focus. Okay. Now, so basically, these are all the roles that you are going to use. As I have told you, you'll be focusing as a data engineer. You'll be working, you'll be learning how to become a data scientist in this particular case. You'll also be working on this particular solution architect. So these are the three roles that we are going to focus in this entire 2 months of career here in this case. Okay. Now, cloud computing concepts. Let's start. So kindly stay for extra some 15-20 minutes of time. In the last 10 minutes of time, I'll take your questions and then we'll leave. Okay. So what is cloud computing? When we say something called as cloud computing, as I have told you, right? You have something like on-premise is there. You have something like on-premise because in your on-premise, what generally happens is everything you need to purchase. The CPU you need to purchase, okay, the computer systems you need to purchase and everything you need to configure, then only you need to start working with particular systems basically. Okay, but in the case of this cloud computing, what happens is there is nothing that you need to have. Only one thing what you need to have is you need to have only your laptop and internet connection. Okay, and what happens is to use a computer system, you can order, you can launch an instance. To use storage, you can use the storage. Okay, to use the networking, you can use that particular networking. That means that everything happens on demand. In the case of this cloud computing, everything happens on demand in this particular case. That's why cloud computing is something like renting resources like storage, CPU, and other companies computers also as well. And what I am saying here, you pay only for what you use. ఇప్పుడు suppose you have purchased a computing system which is of something like 50,000 or 60,000 rupees, and then what you say is that tomorrow a new gaming laptop comes. Okay, now the current system what you are using is not of so much use to you. So what you can do with that one, you cannot do anything, right? Either you can do it as a second sales, or else you need to keep it for yourself, which is a waste. But there, what you're doing is that you're going to pay for the resources what you're going to use. Okay. And the company provides these services, which is called as this cloud provider. So, what are the three major cloud service providers? What you're having here? There are three things. One is Microsoft, the second one is Amazon, and third one is Google. So that means that what are the various services that we use? We use something like compute power, the servers we want to purchase, okay, the storage where we want to have, and the networking, okay, and then the analytics. These are all the things that there is no need for you to purchase and then keep it on your on-premise, but instead what you can do is that in the cloud, from these cloud service providers, you can rent them, okay, and then pay for those systems till the time you utilize, and then you release them to the service provider itself. That's why it is called as pay for what you use. And one more thing is that these are all on-demand resources. On-demand resources means when you want, you can buy them, you can rent them. When you don't want, you can give them back. That's why it is called as on-demand, pay for what you use in the case of this cloud computing. Okay. Now, when you go to this particular place, there is something called as what is this serverless computing is important. Serverless computing. Serverless computing means, see, uh, if you are an ETL developer, if you are an ETL developer, now what you need to do is that you want to you want to execute an ETL program, or else execute an the database query. Okay, for that particular purpose, you'll specify, hey, I need this much amount of RAM, 16 GB of RAM I need, or else I need to specify something like 250 GB of hard disk. Okay, I can have something like IO speed of this many gigahertz per second. This much of configurations that you need to specify before you run your query. Okay, that means that is what is called as provisioning. That means that you need to provision these resources beforehand before running your applications. Before running your applications. But in the case of this cloud computing, what happens is that there is one type of concept called as serverless computing. Serverless computing means there is no need for you to provision anything. There is no need for you to provision anything. What you do is that you just bring your code. Okay, don't bother about the operating system, don't bother about anything else. You submit that code, and the cloud service provider will take care of execute the code and then give you the result back. It is something like event managers. For example, when you want to do a destination wedding in some place, okay, or when you want to do a destination wedding in Hyderabad, something of that sort, what you do is that the couple will go to that function place. Okay, they do the rituals and then they come back. What you need to do is that you need to give that money to the wedding, event organizers. What they do is that they do from end to end. They do from end to end, and they will make sure that they invite the guests. They do all those lunch, dinner programs. They do everything, the fun, the music, the sangeet, and everything. They take care. That is what is called as event management, right? So such like that, when you have the money, when you bring your code, okay, these cloud service providers will take care of giving you all the required platform for the purpose of executing your code and then giving you the result back. Okay, that is what is called as serverless computing. That means that there is no need for you to take care about the infrastructure that is really required in order to in order to execute your applications. That is what is called as serverless computing. See here, serverless computing is a cloud-hosted execution environment that runs your code but completely abstracts the underlying host environment. That means that there is no need for you to think about what is the infrastructure, the operating system, the CPU, RAM, network, and everything. Okay, that means that no infrastructure configuration or maintenance is required or even allowed. Even allowed. That is what is called as your serverless computing. Okay, so here you need to understand two things. One is cloud computing, and second is serverless computing. Cloud computing, what you do is that nothing will happen on premise, everything happens on demand. Pay for what you use, and then rent the things, and then return them whenever you don't need them. Basically, that is what is cloud computing. And then serverless computing is you don't bother about the infrastructure. just submit your code and then get the things back. And the similar example what you're having here is similar example what you're having is that event management what I have told you in this particular case. Okay. Now coming back, I have told you this is
I'm sorry to interrupt. Ravi, this is Kranti. Uh,
sir.
yeah. One quick question. If serverless computing means like the whole server configuration and everything will be taken care, which means that the server is somewhere at a far distance, and that is taken care by the service provider.
Yes, sir.
Correct
Yes,
me. Uh,
yes. Because that won't happen on premise. That won't happen
yes.
on premise. It will be happening at that cloud service provider global infrastructure. Wherever it is there, wherever the data centers are there, they will take care once the moment you submit your application. That is what is serverless. Okay.
Okay. So all the big server will be at a place, and we pay for that service, and they'll give a small chunk of that space for us, and we execute our program. It is like that, right?
Yes, sir. That is what is going to happen. Exactly.
Yeah. Thank you.
No. So here, the virtual machines and containers, we don't really concern about this point of time, but what you are having is serverless. Okay. I told you, right? Pay for the only the amount you consume. Stop guessing capacity. Okay. That means that what I have told you is how much is there are two types of things. What is called as capital expenditure and operating expenditure. Anybody knows what is the difference between capital expenditure and operating expenditure here? What is capital expenditure and what is operation expenditure?
Capital expenditure means it's a investment to start. I mean, to start the an organization infrastructure. Yes. Um, and the second question is to second one to answer bit to
Maintain.
run
Yeah.
yeah, maintain.
See, capital expenditure means whenever we are starting any particular project, the initial heavy investment that what we do, okay, for procuring that infrastructure, the computers, the CPU, the RAM, the databases, the networking routers, gateways, whatever what we purchase is basically treated as uh, capital expenditure. The initial heavy budget, what we do is the capital expenditures. Now to maintain them month by month, what we need to do is that we need to have this operational expenditure. So capital expenditure is a one-time thing that we do, and operation expenses nothing but month on month that we try to incur. Okay. Now here what we are going to do is that in the case of cloud computing, there won't be any capital expenditure. The reason is you are not purchasing any infrastructure. You are only renting the things, right? That's the reason what we do is that we only pay for the amount you consume. The second thing is that increase speed and agility. Last time who has asked me the question, they have asked something like, hey, when I want to purchase a computer, okay, and I need to order, they need to deliver, we need to configure, we need to install the applications, and then we need to start. Will this happen all in one night or 1 hour? Can it happen basically, Arun, Ishwar, Jaykumar?
Sorry, sir. Can you come again,
No.
Ravi? Sorry, I
No,
missed it.
what I'm saying is when you are planning to purchase a computer, install the applications, configure everything, and then when you want to use that computer, everything can happen in 1 hour or it will take days and months and
It
weeks.
will take days. Obviously, it takes days.
It will take days. But here,
Yeah.
this is just like this.
Yeah.
For the
Pre-configured.
purpose of for the purpose of spinning a computer, for the purpose of renting a computer and then design your website and then post that website publicly, it can happen within 30 minutes. It can happen within 30 minutes. Okay, that is what is called as increased speed and agility. Increased speed and agility is something that we do. Minutes for minutes only to make the resources up and running, and there is no need for you to maintain any data centers. There is no need for you to maintain any data centers. And then what you're having here is that you can have the option of going global in minutes. What do you mean by global in minutes? For example, uh, for example, for example, you are installing you are hosting a website, and then I want to make sure that this website can be hosted across all the regions within the globe in order to do this powerful marketing. Such type of thing can happen in uh, cloud computing. For example, you are in India and you want to host a server, or else you want to spin a server in Virginia or Ohio and all those particular places, you'll be able to do it. That's why it is called as global. These are all the advantages and benefits of using cloud computing, but the other option what you are having is on-premise. What we have been using is nothing but your on-premise. But the thing what we are planning to use is nothing but your cloud computing. These are all the advantages that you are going to have. You are not going to have the capital expenditure. You are going to have only the operational expenditure. You are going. You are not going to. You are not going to purchase anything because you are going to rent them, and you pay only for your use. You pay only for your use, and then stop spending money on running and maintaining data centers, and we have the option of going global in minutes basically. So I have told you all these things basically. Global, secured, and all these things will come in the benefits of cloud computing. Now, so when selecting a cloud provider, you should understand how the cloud provider can help you with these questions. How compliant is your cloud service provider when handling sensitive data? Because in US, when you're here, we'll be having something like social security numbers that exist. Okay, or else you can have something like credit card information and all other information is there. You cannot simply go to the cloud and then store that credit card information in the cloud, right? Basically, this is the place where you can have the option of encryption and decryption that will come into the picture. Okay, you need to encrypt the data before you send it to the public place. Cloud is a public place, right? And how compliant are these services basically? How can I deploy my own cloud-based solutions that can have the accreditation and compliance requirements? Okay, what terms of the privacy statement for this particular provider? That means that you need to be very secure. We will be very concerned about the security and the privacy of your data when you're hosting on that one. So all the cloud service providers, what you're having here, like Azure, Google, or Microsoft, Azure, Google, or Microsoft, Google, or AWS, they'll be using this particular compliance terms and procedures in order to make sure that you need to keep your sensitive data. Ravi Kumar M, you have seen, right? When you're trying to create a password for one of the instances, it says something like, this is a very openly, easily trackable password. That's why kindly change your password. When you try to create that password in Redshift, it is showing you, right? So such type of, and so much security certificates, so many encryption and decryption mechanisms are being heavily used in order to maintain your compliance and security requirements in this particular case. Okay. Now, what we are having is that economies of scale. Example is that, see, if you purchase, there is a difference between you renting one computer or one virtual machine, or when you're renting something like 100 virtual machines. Okay, that means that when you consume more amount of information, okay, or when you consume more amount of resources, automatically what happens is that the cost will drastically go down. The cost will gradually go down. So that is the main benefit of this one. That means that when you try to scale your resources, scaling up means when you try to when you try to use using more memory, more CPUs, more instances, more database power, more networking, obviously what happens is that you will be you'll be paying less when the consumption is more. That's why what happens is that are leveraging the benefits of economies of scale. ఇప్పుడు ఏంటంటే for Azure or AWS, the number of customers are in thousands, hundreds, and millions. Okay, that's why you holding the whole property, or else multiple people holding the same property, the cost will be less, basically, right? That's why the whole cost that can be incurred on one person is being distributed across multiple persons across the account. That's the reason what happens is that you will be ultimately liable in paying less than what you are supposed to pay. That's why this is what is called as economies of scale that you can see with this case. Then I told you something like capex or opex. Capital expenditure is the spending on the money on the physical infrastructure upfront, and then deducting that expense over time. This is your upfront cost. But month on month, what you are doing is spending your money on the services billed from then onwards. You deduct this expense in the same year. There is no upfront cost. So, cloud computing law, Ranjan, what is more and what is less? Ranjan P.
Yeah, hi. So cloud computing, as I understand, is the serverless infrastructure, and we we only that amount of space we used at the same time. So this is not burden of the infrastructure of the of particular individual or organization.
Yeah. So that means that when you are using cloud computing, what happens is operational expenditure is going to be more and capital expenditure is going to be less because you are not owning any resources basically, right?
Yeah, correct.
Yeah. That is what we are going to use here in this particular case. So that's why you can be able to see the difference here. That is when you use your on-premise data centers, you're having the server cost, storage cost, network cost, backup cost, data center infrastructure cost, and then technical personal cost will be there on the case of this on-premise. But on cost, a typical on-premise data centers, leasing a cloud-based server, leasing softwares, scaling use of demand and so on, billing at the user and the organization level, basically that happens with respect to this. CapEx versus CapEx in this particular case. See, we lease, but here what we do is we own, basically. We are leasing the softwares. We are scaling charges based on the usage and demand in the case of operational expenditure, billing at the user level. But here, the whole organization is going to be built here in this particular case. Because when you try to bill at the user level, that is what is called as the subscription based bills will be getting. How many users you are having, that many users are going to be built in this particular case. We can't say that it is totally zero, but a minimum thing will be there, sir, basically. Minimum things might be there. See, Sandeep, even though you're using any cloud also as well, for accessing the cloud computing resources, don't you need to have a laptop for you?
Yes, it is required.
So that's why I can't say that it will be zero, but it will be minimum. Suppose, yeah, on-premise, when you are mentioning something like 1 million that you are going to spend, okay. But in the case of when you go for cloud computing, the capital expenditure might be something like 10,000. You can use $10,000. There's a difference that you can have between that one, basically. Got it. Cloud deployment models. How many types of clouds are there? Is Azure, AWS, or Google a public cloud or a private cloud, guys?
Public clouds. Those are public clouds.
Those are all public clouds. Why are they public clouds?
The resources are shared among, mm,
Resources are shared among
I mean,
whom?
whoever has the subscription.
Across the subscribers.
Multiple customers, multiple users, multiple accounts will be utilizing that cloud-based system, right? That's why it is public cloud. Okay. Private cloud means, what is private cloud?
It is a dedicated cloud environment for one specific customer.
On particular purpose.
Ante, if you are maintaining
Within the
your cloud,
organization, they can put it up.
uh,
You have a only infrastructure for you.
yeah, that
You-
means that if you are using such type of cloud-based services, the same cloud-based services what you are having within your own data center, then what we do is that we call that one as a private cloud. We call that one as a private cloud. Okay, that means that even within the cloud, you will only be the account holder. You will be utilizing those cloud computing.
Sorry, Ravi. Can you come again that point? What's a data center and a private cloud? You said that statement.
See, uh, you know what is virtualization? I was telling you in the previous things called as virtualization, right? What is this
Yep.
virtualization? In the case of this virtualization, what happens is this is one host computing system. Okay,
Oh.
this is one physical server. Within this servers, what I'm doing is that I'm spinning multiple virtual machines, right? You see this one?
Yep.
That means that is it not something like one system is being utilized by multiple people across the machine itself here? This is being
Yep.
used, right? Okay.
Yes.
If this virtualization is being implemented on your on-premise data center, where your company people are only the people, you will be utilizing this such type of virtualizations basically. Then such type of cloud is what is treated as the private cloud. Got my point?
Oh. Okay. Okay. Thanks.
Okay. Now there is another type of thing. What you are having here is nothing but your hybrid cloud. What is that hybrid cloud? Suppose I'll tell you here. Banking systems or insurance companies or financial systems, what they do is that due to the government regulations, we cannot host the entire data within your public cloud. Vinita, you are following, right? The entire data cannot be hosted on the public cloud. Okay. So they want to keep their secured and personal information within their private cloud. And what are the information that can be given to that general public, they can keep in that public cloud. Okay. In such a case, trying to maintain the harmony between both the public cloud and the private cloud and keeping your information in those two places, such type of cloud is treated as this hybrid cloud. Such type of thing is treated as this hybrid cloud basically. Okay. There are places like when I'm working for Disney, what you really have is Disney have their own applications existing in Azure, and then they have their applications existing within AWS also as well. Okay. So when your proprietary information is existing in multiple clouds, we call such type of cloud as a hybrid cloud in this particular case. Is it making sense with you? This is what is a public cloud. So here, public cloud, you see here. Pay as you go pricing, you are responsible for the maintenance and upgrades of your hardware. And one more thing is that uh, there may be security requirements that cannot be met using the public cloud. As I told, right, governmental policies and insurance standards, we can't use these public clouds. We don't own the hardware services and cannot manage them because it is managed by the public cloud. This is what is your public cloud here. Okay. Then coming back to your private cloud, I told you, right, you can ensure the configuration can support any scenario or legacy application. Private clouds meet strictly security compliance requirements, economies of scale, and integration with the Azure Security Center. But disadvantage is you'll be having initial capital expenditure. Where are we maintaining these things, Sandeep? I think who was the person who has asked to repeat that explanation of that private cloud? So here, I told you, right, there is something like a virtual machine. When you are purchasing that virtual machine, it is your expenditure that you're going to pay, right? So in such a case, what happens is there will be an initial capital expenditure that will be used while using these private clouds. Basically, you have some capital expenditure costs and might purchase the hardware for startup and maintenance. This is basically treated as a virtualization. Basically, when you have your own data center and then when you keep all your data over there, that will not be treated as a public cloud. That will not be treated as a private cloud. You need to have that element of virtualization that should exist, where the single resource power can be shared across multiple users or multiple machines. That is the place where this private cloud comes into the picture, like VMware. Those things will be used basically. Okay. And a hybrid cloud, I have told you, right, combines both public and private clouds, allowing you to run your applications in the most appropriate location. You can host a website in public cloud and link it to a highly secured database hosted on your private cloud on your on-premise data center. Such type of thing is what is called as hybrid clouds. So hybrid clouds are very rare. Of course, they are not that frequent when compared to public and private clouds. But nowadays, the things are moving towards this public cloud only. Those are all your types of cloud deployments. Kindly understand this is what is your cloud deployment models. Okay. Now, the other thing what you are having here is we'll be talking about the types of cloud services. What are those services? IaaS, PaaS, SaaS. What is this IaaS? Infrastructure as a service, platform as a service, and third one what you are having here is software as a service. Can anybody give me an example of software as a service? Give me an example of software as a service.
Zoom is an example for SaaS.
Inka?
Email.
Databricks, can we assume Databricks as a software as a service, or Azure SQL database?
Can you tell me any simple terms or several simple examples?
Gmail.
365 Gmail.
Gmail as
Office 365.
Gmail and Office 365 are the examples of software as a service. Why it is called as a
I mean, basically, any application installed on the server, which we can use, can be termed as software as service.
Kadan. No.
Huh?
No. What I'm saying is, not sir. Every application installed cannot be called as a software service. See, I don't need any infrastructure. I don't need any virtual machines. I don't need any application. What I want to do is that I just want to use that feature for doing some activity. Like when you use Gmail, what I do is that I can compose a mail, I can send it, I can receive the mails, I can delete the emails. So only if the user is limited only to that interface, then such type of thing is treated as software as a service. The Salesforce CRM, what you're having is a software as a service. Microsoft Dynamics CRM is software as a service. Software as a service. And then Google, Gmail and Office 365, Dropbox, Google Drive. These are all examples of your software as services. Okay. Now, what is infrastructure as a service? Any idea? What is infrastructure as a service?
They will give the hardware. Our cloud provider will provide the hardware, and we need to install our applications on top of it.
Yeah.
Correct me if I'm wrong.
No. You're good, sir. You're good. They will provide only the hardware. I'll show you one slide. Please follow this one here. You see this one. You'll be understand. On-premise. I told you, right? Can somebody kindly go on mute if you don't mind? Okay, thank you. The reason I just asked is just creating some echo. That's the reason I just asked. Okay. So when you go for this on-premise, what you're having is these are all the things that you have. Networking, I told you. Storage, you need to have. Servers, you need to have. Just now I told you something called as virtualization. Virtualization means when you need to develop a VM machine, virtual machine, that is your virtualization. Like that, on my system, I can have 3 or more virtual machines that I can spin. You have this OS, middleware, runtime, data, and applications. These are all the things that will constitute the resources of your computing system, right? So on-premise, who are going to manage? You are the person who is going to manage all these components on your system. No one else. That means that your infrastructure people and your administrators will be responsible for the purpose of doing all these things. Okay. Then in the software as a service, who is managing? Provider manages. Who is the provider? Google provides Gmail. Okay. Microsoft provides its CRM, Dynamics. Okay. And Microsoft also provides that Office 365. Okay. That means that the networking, the storage, servers, OS, and everything is being maintained by them. As an end user, we are utilizing that particular application in order to run these things, in order to run your operate that particular software. That is what is a software as a service. These are the two extremes what you're having. Basically, everything is managed by you is on-premise. Everything that is being managed by the provider is nothing but your software as a service. But these two things are really important. For example, infrastructure as a service. Somebody has told, who has told that one, sir? Somebody told, who is that friend who told?
Ravi. Ravi.
Is it Ravi?
Yeah.
Yeah, OnePlus, right? OnePlus, right?
Yes.
రేపు నుంచి ఆ పేరు మార్చి కొంచెం పేరు పెట్టండి.
Yeah, sure sir, sure.
So what he has told is I'll be given that bare hardware, bare motherboard or bare desktop I'll give. On that one, what you're having is they give you that networking, they give you the storage, they give you the servers, and they give you this virtualization. What all you need to do? OS you need to install. The OS patches you need to install. Databases you need to install. Middleware you need to install, like Cobra and all those particular things. JRE, Java runtime environments, everything you need to install, and you are responsible for these things. This is what is your infrastructure as a service. This is what is infrastructure as a service. For example, when you are formatting a system, formatting your total desktop, everything will be bare, right? Like something like when you are doing a factory reset for your mobile, that means that everything is empty. They give you that only that skeleton. Within that skeleton, you put the operating system. On top of the operating system, you put the operating system. On top of that operating system, you put that middleware. On that middleware, you try to run your data and your applications. All these particular things constitute your infrastructure as a service in the case of your IaaS, basically. Okay. Now, like when we are talking about something like Appium or workflow collaboration programs, what they do is that they will give you the platform. They will give you the platform like Elastic Beanstalk, or else these are the platforms what they give you. So that means that what you need to do is that you are responsible for writing the code and the data of those particular applications, and everything else is being maintained by this provider. That is what is called as a platform as a service. Platform as a service. For example, when you try to take this Amazon Data Factory or Glue, all these particular things, what you do is that they give you that application, they give you that runtime. Okay, when they give that particular runtime, what you need is that you need to design your own applications, and then you are the control of your data, but you really don't have any control on these underlying things, basically underlying things. Then in such a case, such type of system is treated as a platform as a service. So that's why this question Databricks is software as a service, sir. Synapse is software as a service. ADF is basically a platform as a service.
Ravi, sir, any application that accessing from the web, so we can consider it as an software as a service.
Can you tell me one example?
Like any application, like for example, as already the people sell like Gmail, any email,
that is software as a service. Yes, sir.
like any application that accessing in the Gmail in the browser, so we can consider that as a software as a service, right?
Yeah, we can consider that one as software as a service. Yes, sir.
And basically, the platform as a service and software as a service both are correlated. It's not like exactly the independent, but they're all the correlated as a
correlated. Kani, when you are using Gmail, you don't write any programs, right? Basically, you don't write any programs.
Yeah.
Okay. But when you try to use something like Azure Data Factory or Glue, what you do is that you write the applications, right, to transfer the data. You write those applications to transfer the data.
No, exactly. We are not developing any applications. We are using it, right?
Then which one you are talking about?
Like Azure Data Factory.
Azure Data Factory, you need to develop your ETL pipelines right over there.
Right, right. Okay.
You need to develop the application. And you have your own data. The data is yours, right? Basically,
Correct, correct. Yes.
that is what is treated as platform as a service.
Okay.
Okay. So this is how these are all the things. So what we are calling here, this is being called as types of cloud services. Earlier we have talked about types of cloud deployments, and then we are calling them as types of cloud services. These are the two things that are really, really important in this particular case. Okay. Okay. So when you go to this public platform here, I told you, right? Uh, Analytics and business intelligence tools allows the organizations to analyze and mine their data. They can find insights on all this, the Tableau, the Power BI, and all those particular things. See, PaaS lets developers create applications using the built-in software components. You understand, sir, what I'm talking here? Using the built-in software components, they allow you to develop those particular applications. Okay. PaaS is a complete development and deployment environment. Development you do based on the platform they are giving. Okay. When deploying a web application using PaaS, you don't have to install the operating system, web server, or even system updates. Everything is being taken care by the provider. That's the reason it is treated as PaaS. Okay. So that's the reason I have told you here. See, I have told you, right? CRM Dynamics, Skype, Office 365, these are all the things that you need to do. You need to pay for this monthly subscription, basically for the purpose of utilizing those features. That is what is called as software as a service. So in on-premise, everything is in your control. In SaaS, everything is in the cloud service provider control. But in the other things, there is a blend that you're going to have with respect to this particular scenarios. Okay, that's what is your cloud. What do you say here? These are your types of your cloud services. And earlier, whatever you have seen here, these are nothing but your cloud deployments, what we call deployments, public cloud, private cloud, and all those particular things. Still, Amazon happens to be the leader here, but this is giving a tough competition with respect to the market share what you're having with respect to those particular sources. Even in the current scenarios as well, this is the same thing that you are using here. You have this IBM cloud also as well, but these are the three prominent factors that you are having in this AWS. Now coming back to this Microsoft Azure, what I can do with Azure? I told you, right? Azure provides 100 services that you can enable to do everything for running your existing applications on virtual machines to software paradigms. So Azure is going to be like this. You can launch a virtual machine, Windows virtual machine. You can develop a web application. You can develop a data-driven app. You can build a serverless app. You can store and transfer data as well. These are all the things that you can build in how much time, Vinita? This is what is Azure. So that's why Azure is going to have a lot of services here. You have this media, you have this integration, you have this compute services, developer services, application platform, data, intelligence, and analytics. This is the focus that we are going to focus here. Or data engineering, what you are having here is going to focus on all this particular part. Okay, but I have told you, right? There are some core components. So can somebody tell me what is the purpose of those core components that we are talking here? What are those core components?
Services components like data lake, data.
Compute is a core component, right?
Yeah, component, compute and storage and
Networking.
Networking.
Yeah, these are all your core components. If you lack you are and security also as well. Security.
We can say foundation services.
Now, foundation services.
Correct.
AWS we call that one as core services. Here you call this one as foundation services.
Correct. Correct.
Okay. So these are all the services that you need to have a good hands-on before you start working on these things. Do you agree with me? If you don't know how to utilize these particular
Yes, sir.
services, you will not be able to work on this because these are all the foundational services that we want to have. Okay, so initial part of the course we'll be seeing how to spin a virtual machine, how to use this particular blob services using storage, and then how to set up this particular networking. We'll be seeing them in a couple of classes, and then how to set up this particular security and management also we'll be seeing with the help of this Azure Active Directory and all those things we'll be seeing. The moment once we see them, then what we do is that we come up with this particular core components of this architecture, what we are supposed to use here. What are those components that I talked here? Those components that we are talking here is something like, see here. 1 minute. These are all your core components that you're going to talk. Data, intelligence, and then analytics and IoT. Within this one, we talk about the 60 insights, machine learning, data like analytical services, all the things. So today, with respect to this Power BI and the data bricks also, we'll be talking. Okay. Now, when we try to delete this thing, clear all it runs. Okay. And here when this one will be able to go back here. So we'll be talking about these networking services. We'll be talking about the compute services. We'll be talking about the databases. In the databases, we'll be talking about this database migration service, SQL database, Cosmos DB you'll be using, and Azure data from MySQL. We'll be talking about analytics, the data factory, the SQL data warehouse, which is called as what? Synapse, Azure Data Bricks, Stream Analytics, and Azure Analysis services will be doing. Storage we really don't touch, but we talk about this particular blob storage. And then Azure Data Lake also will be talking here. Internet of Things we really don't do much here basically, but these things we are not really concerned. But the core services and Azure architects and guarantees, these are all the things that will start from Tuesday. Okay, so that's what I want to talk today basically is how is on-premise going to be different from your cloud computing environment, and what are all the features that you are having, and how it is going to be different. So what is the capex, what is opex, what are these uh, what are these cloud deployment models like public, private, and hybrid cloud, and then what else is this types of cloud services in terms of IaaS, PaaS, and SaaS, in terms of this on-premise, and what is virtualization, okay, as well as what are the different types of services that we are going to see. The core and all the different services we'll be focusing on in order to make sure that we just start our journey from next week. Okay, that is what is the plan. Okay, now a couple of things that I want to tell you here. In this course, I'm going to focus on 4 things basically. Please listen carefully. I'm going to focus something on Azure Fundamentals. What is the code for the Azure Fundamentals? Anybody can tell? What is the
Service compute
AD9.
storage.
AG900, right? AG900.
AG900.
I told you something like we'll be focusing on this AG900, and I want everyone, I encourage everyone to complete that certification in the middle of this particular course, AG900. Okay, and I'll be motivating that one in a great level. That is one thing that I'll be doing. The second thing what I'll be focusing on is I'll be focusing on this Microsoft Azure Data Fundamentals. So let me do one thing here. Let me stop this one and then go to this Google thing and then bring this one here. What is the one thing that I'm talking here? Give me some 10 more minutes, 15 more minutes, and then we'll talk here. Okay, please. Google, this is AG900. What is this one? This is a fundamentals examination preparation. I want you to complete this one. Fundamentals data types. And the other thing what I'm having is that I'm talking about something like TP900. What is this TP900? This MP900 is something like Azure Data Fundamentals. I want you to focus this one too. Very, very important. How much does TP900 cost? $99. That's okay. And what is the major thing that we are going to focus? What is the major certification that we are going to focus? Name it.
203.
203 is the major thing that we are going to focus. Data engineering and making Azure. This is going to set the trend. This is going to set the trend. And along with this one, we are going to focus on this. We are going to focus on this Power BI and Data Bricks also as well. The same way, not more, not less. On par with Azure Data Engineering, we'll be looking into this Data Bricks with PySpark and the Power BI penetration to this Databricks and Microsoft Azure Data Engineering. These are all the things that we are going to do in this particular curriculum. Okay, so the course will go for 2 months minimum, 2 working months I'm talking about. Okay, where by the end of the course, I encourage and I'm going to push everybody to do the certifications of this DP 900 and AG 900 in the middle of the course itself, and then I'll be asking you to focus. I am telling you the certifications what you earn is going to add a real value and knowledge to you, okay, at the end of completing this particular course. So that's why this journey is not something like the normal journey what you do with the other training courses. Basically, this is something different. This is something different. I focus, I encourage, and I follow, making sure that you understand these particular concepts before you start diving deep into those other areas also as well. Okay, so I'm really interested only about the serious learners. See, today is Friday here, which is around 11 o'clock. There, India, it is Saturday. Okay, a lot of people from US have joined. A lot of people from India also have joined, and we are here for a reason. We are here for a reason. Okay, when I say that we are having for a reason, we are going to talk about data. Okay, and this is not the first batch I'm doing, and I have been doing a lot of boot camps, not only on Azure. We do on a couple of folks are there here also as well. We do the boot camps on AWS, Snowflake, Databricks, and I do the boot camps on machine learning and AI also as well. Okay, so that's the reason I just want to induct the machine learning flavors into this particular platform so that you will be passionate about this particular data journey, and then you'll be appreciating yourself. And then in 2024, I just want to make sure if you are a fresher, if you are looking for a career change, or else if you are looking into the leadership roles as a CTO or chief data architect or a data scientist of that particular matter, when you want to accelerate in your new roles, this is the course that is going to be meant. And then I have told you, right? If you are serious, I'm damn serious for making this course a very productive one in order to make it more official, basically. Yeah, J. Kumar, you are trying to tell me something. Please tell me, sir.
Actually, Ravi, what I told yesterday, I have 14 years of experience how to convert my things into the data engineering. Already, I worked as a data warehouse as well as the ETL things in Informatica data stage, and a little bit on Snowflake recent projects I have worked at.
Okay. I'll make you into a chief data architect or principal solutions architect in data.
Oh.
Because the ETL, that Snowflake, the other things what you have done, we are going to utilize that particular experience, and then we'll make you to shine in this particular Azure that will take you from the place where you have started, okay, expanding your curriculum in order to take you to that data scientist level. And well, if you're serious, we'll be able to work on that one, sir, basically.
Okay. Okay. Yeah. Thank you.
So, yeah. So I told you, right, for whoever whoever have come from Visualpath, okay, only give that numbers to Visualpath. Kindly, it is a request. Whoever have come from my side, please provide your details to me, and I know my people. And you are also my people too. Whoever have come from Harsha trainings, please provide your numbers to that Harsha trainings too. Okay. So maybe our audience are different, but we are going to work on a common goal in order to make this happen, basically. Okay. So, so Jaykumar, I told you, right? We'll be having the next couple of sessions that you can take, okay, without having any influence on whether to join or not. You will Tuesday, Wednesday, and Thursday, you can attend these particular free sessions. But from that particular point of time, your respective management will be asking you to register for this particular course. At the time, kindly cooperate. Okay.
Sure, Ravi. Yeah, I will do that.
At the time, kindly cooperate. But once the registrations are completed from everybody, see, as per the protocol, I would like to discuss with you, Jay Kumar. But if that is the path of your visual path where you are coming from, that would be great for now. Okay, because
Sure, Ravi. Yeah.
I have some protocols that I need to follow. I'll do that one.
That's
But next week onwards, we are going to create another WhatsApp group called as Azure Data Warriors. And within the data warriors, we are going to be all the part of these things. And we'll be making our way into 2024 with a great path into this one, basically. Okay. That's what I
sure.
can say. Yeah. Any other questions before Vinita, you're following?
Yes, I am.
Okay, thank you.
Ravi, for actual class from Monday onwards, it's same time, right? Starting?
But this is the first class today. The
Okay.
will be on Monday. Where are you from, basically? India or US?
India.
India, it will be Tuesday, sir. It will be Tuesday.
Okay. Tuesday same time, right?
Same time. Tuesday to Saturday, same time. Yes. Tuesday to Saturday, same time.
Okay.
Sandeep, the major focus is on data engineering, not data science. Sir. When you talk about data science, it includes ML and other things also as well. But this will be more major of data engineering.
Thank you, sir.
Ravi, I have a question.
Yes, sir.
Shall we discuss SQL and PySpark in this course?
Yeah, we are going to discuss. Yes, we are going to discuss.
Okay.
We'll be discussing, sir. We'll be discussing in depth. PySpark with Data Bricks and the Azure Data Factory. We are going to combine and then we'll be discussing them too.
Hey, Ravi, I have one question. So regarding that certification, so how we can clear at a time it will clear and base means it's a difficulty or challenges in
The first AG is not that difficult. I think you should be able to clear. I'll be providing you the complete material, how to cover that one. Okay. And I'll be guiding you also as well to complete that 900. Once you complete that 900, you'll be getting to understand, you will be able to understand the passion, how to complete that, what is the other one? DP 900. Once those two things are done, you'll be yourself to complete the DP 203 also as well. Okay. I'll be taking one at a time, not all at a time, one at a time, one at a time. Okay.
Sure, Ravi. Already I have registered for that.
Great.
Next time. Yeah.
That's it. See, I have my friend, my own dear friend, is there or not? I'm just checking. He's left, I think. The Kumar who had joined already has completed Snowflake in the second week of our bootcamp itself. Okay, such type of people are there. I love to see such type of certifications from the people. Yeah. I see you all on Tuesday Indian time and Monday US time, same time, and then we'll take it from there. Thank you so much for your time. I appreciate it a lot. Okay, I hope we'll be meeting soon in the next days and then we'll take it from there. Okay, thank you so much.